Hi there, it's Marco again. And after our play we did yesterday, it got me thinking, how many different creatures around the world, especially marine creatures, end up getting killed because of plastic, because of pollution? So I did a little research, and here's what I found. I found that approximately 1,000 sea turtles every year die because of plastic pollution in the oceans. Approximately 100,000 different marine animals die from plastic pollution every single year. And approximately an additional 1 million seabirds die every single year because of pollution. Now, I don't know about you, but I love these super, super wonderful little turtles. They're terrific turtles, if that. But at any rate, I don't want to see these things dying. So we need to try to do a better job of making sure that we don't pollute our waters. Now, beyond that, I want to look at those numbers that we just talked about, that about 1,000, about 100,000, approximately 1 million. When you hear those words, I love those words because they're estimating words. Now, obviously, we don't know that there's exactly 1,000 sea turtles that end up dying. It could be more. There's those are just the ones that are found, and it's probably not exactly 1,000. It might be 1,012, but it's easier to just say 1,000. So today we're going to be looking at how we approximate different square roots, because remember, not every square root that we take is going to be a perfect square. So things like the square root of 36 is 6, that's right. But the square root of 30, that's not a perfect square, but it is between 25, which is a perfect square, which is 5, and it's between 36, which is perfect square, which is 6. So that means the square root of 30 is going to be somewhere in between that. We're going to discuss that a little bit. Also, we're going to look at how to take some square roots of some fractions and decimals, but not super hard ones, just some basic ones to give you an idea of how working with square roots can work with special kinds of numbers and how to approximate square roots.
So square roots, we're looking to try to find what number times itself will give you the number underneath that radical sign. Now, like we said, a lot of these numbers are what we call perfect squares. They're the numbers that work out really well. Numbers like what you see here on the screen. The square root of 25, well, we know from our times tables that 5 times 5 equals 25. So the square root of 25 is 5. We say that this number 25 is what we call a perfect square. It's a number that easily has a nice whole number or an integer as a square root. We take the square root of 196. We should remember from our list that's another perfect square. Square root of 196 is 14 because 14 times 14 is 196. It's this 196 that's the perfect square. Now we take the square root of 49. We should remember that 9 times 9 is 49. 9 times 9. Sorry, 7 times 7 is 49. And then we take the opposite of that. So that would be a negative 7. These numbers are all perfect squares. They work out perfectly. They give us whole numbers. But not every number is going to work that way. So what we have to do is we have to have a rough idea of what we're going to have for our result, because we've all punched numbers wrong on a calculator. Now, the great thing is that you get to use a calculator to find the square root of something like 26, and 26 is not a perfect square, but it's a good idea to have an idea in your head before you even type anything into the calculator of roughly what should this be. So let's see, square root of 26, not a perfect square. So what we want to do is think about what perfect squares are on either side of 26. Well, 25 is a perfect square. And the square root of 25 would be 5. And then 36 is our next perfect square that's just bigger, and the square root of that would be 6. So now we have to just decide which would it be closer to. Is the square root of 26 closer to 5, or is it closer to 6? Well, clearly we can see because 26 is only 1 away from 25, but it's 10 away from 36. 26, the square root of 26, is going to be way closer to 5. It's going to be 5 point something, and probably something fairly low, like maybe a 5.1 or something like that. But for our purposes, we just want you to be able to tell us to the nearest whole number or the whole closest integer what these square roots are. Let's do another one. So let's suppose we had the square root of 59, and we wanted to find out what that is. Now, 59 is not a perfect square. It's not on our list. So we have to estimate to the nearest whole number or the whole closest integer, what the square root of 59 is. So let me think, what perfect squares are below it and what one's above it? Well, 49 is a perfect square, and the square root of 49 is 7. And then 64 is just above it, and the square root of 64 is 8. So we know that the square root of 59 is going to be somewhere in that 7 to 8 range. It's going to be 7 point something, but which is it closer to, 7 or 8? Well, let's see. 49 is 10 away from 59, and 59 is 5 away from 64. So we can see that clearly 59, the square root of 59, is going to be closer to 8. Now, it's still going to be, when we type into our calculator, 7 point something, but to the nearest integer, we would say that the square root of 59 would be 8, because that's the whole number that it's closest to. If you wanted to get all kind of technical to have a bit closer idea, maybe it would be something like 7 point, I don't know, 6 or 7.7, something like that. But for our purposes, we just need to the nearest integer or whole number. All right, what about this one? Let's suppose we wanted to find the square root of, I'm going to make it a tricky one for you. Negative 110. Now, 110 is not a perfect square, but below it we have 100, and we know that the square root of 100 would be 10, but we're talking negatives here because we have the negative on the outside. And then larger than that, we have the square root of 121. The square root of 121 is 11. So now the question is, which one would this be closer to, negative 10 or negative 11? Well, we have to look at our numbers here. Well, we see that 110 is 10 away here. And we see that 121 is 11 away. So although it's really close to being dead smack in the middle, it is a little bit closer. So we'd say the closest integer would be negative 10. Now, if you wanted a really good estimate, it's roughly about halfway. It's probably something even closer to negative 10.5. But for our purposes, we just need to the closest integer. So which perfect square or square root of perfect square is it closest to? So we also are going to have to be able to be comfortable with working with certain fractions and decimals, taking square roots. And we're not going to get crazy on giving you really tough ones. But we might see, for example, something like this, 0.36. Now, 0.36 is not a perfect square. It's not on our list. However, we should recognize that number 36. And 36 to us means 6 times 6. So this 0.36 can be made up of some sort of a 6 times 6, because that gives me 36. But now the question is, how would we get our decimal here? Well, we got to remember how we work with multiplying with decimals. In order to get it to move 1, 2 places, that means we have to have 2 places here when we're working with our multiplication problem here. So if we multiply 0.6 times a 0.6, that would give us our 0.36. Let's do another one of those. Let's suppose we had the square root of 1.44. Now, the square root of 1.44, that's not a perfect square. However, 144 is a number that you should recognize because the square root of 144 is 12. So more than likely, this 1.44 is going to be made up of some sort of a 12 times 12, because that gives us the digits of 1, 4, and 4. But the question is, where do we put that decimal? Well, at first glance, you might think, oh, we'll just put it here, 0.12 times 0.12. But that would make us have to move that decimal over 4 places, which would give us this. So that's not what we're looking for. So we got to fix that. Oh, I erased too much. So what we're going to want is, we want it over 2 places. Well, some of you guys may have already figured this out. If we put the decimal right there, 1.2 times 1.2, because remember, the 2 numbers have to be the same numbers that we're multiplying to get us that result. And that's going to give us our 1.44. So let's talk a little bit about fractions. So let's suppose we had something like this one. We're going to keep these numbers that work nicely with perfect squares. The neat thing about this is, what we're talking about is we need some sort of a fraction times another fraction that gives us 9/49. And if you think about what's going on here, when we multiply fractions, we multiply this top number times the bottom number. We need to be sure that they're the same numbers. So we need a number times a number that gives you 9, and a number times the same number that gives you 49. So in essence, we can look at this as the square root of 9 over the square root of 49. We know that the square root of 9 is 3, and the square root of 49 is 7. So when we see a fraction underneath that radical sign, we can split up this numerator and denominator and look at it the square root of the numerator over the square root of the denominator. Let's do another one. Let's do another one just like the other one. So how about this one? Ooh, this is a tough one. So the square root of 1636. And again, we're going to try to keep these so that way these fractions work really nice for you. But this one's a really tricky one. So, like we just said, whenever we have a fraction underneath that radical sign, it's the same as if we look at it from this standpoint. It's like we're just taking the square root of the numerator over the square root of the denominator. If you recognize that that square root of 16 is 4, square root of 36 is 6. Now we're nearly done but that 4/6 can be reduced because we can divide each one of those by 2 and we get 2/3. So far, so good. But now I want you to double back here to the original. Some of you might have looked at this 1636 and said to yourself, well, wait a minute, 16 and 36 can both be simplified, and they can. 16 and 36 have some common factors. 2 goes into both of those. Well, we can go step by step. If you divide both of those by 2, sorry, I need a little bit bigger, you would get 8 over, what do we get here? Over 18. But then we could multiply or divide both of those by 2, and we would get 4/9. Well, the square root of 4/9, well, the square root of 4, because now we can split this up, square root of 4 over the square root of 9, still gives us our 2/3. Or if those of you back here realize you could simplify by dividing by 4, it would have brought us right here anyway. So no matter how you go, no matter how you slice it up, you still get to the same places. So the key thing to keep in mind is remembering that we're always looking for those perfect squares and numbers that work well with those perfect squares. And when you're estimating, just look at the nearest whole number or to the nearest integer if you're talking about negatives, positive, or negative whole numbers.
Okay, so there you have it. How to find some square roots of some fractions and some decimals that look a lot like our perfect squares, but also how to find an approximation of some square roots that are not perfect squares. Remember, it doesn't have to be perfect, but we want to try to get it as close as we can, making reasonable assumptions based on the perfect squares that we do know, which is important to know those. Then we can start to approximate what some non-perfect squares will look like. All right, folks, so behind me, we have another one of these beautiful sea turtles getting released back into the wild. I got my little turtle right here. Hello there, how are you? Oh, I'm just fine. All right, terrific turtles, go do your work and be awesome.
Hey, boys and girls, look what I found. It's a tiny little painted turtle, and he's moving really fast. Remember I told you how the big turtles move really slow, but the little turtles move really fast? I have to remember to wash my hands when I get home though, because they carry a different kind of sickness than we are worried about right now. Something called salmonella. Isn't he cute? Ooh, he's adorable. Or she. I don't know if it's a boy or a girl.